Hello, folks. Welcome to So Nasty Entertainment. I'm the Crazy Critic, and it's time for a critical reaction. Okay, I found this interesting article on the Scientific American called The Physics of Poop by David Hu, Patricia Yang, and The Conversation. And I do apologize for pronouncing either of those names wrong. Before we get too deep into this article, just want to say thank you for supporting the channel. You can continue showing support by smashing that like button, sharing the video, subscribing to the channel if you haven't already, and feel free to leave a comment. This article starts out by saying, why it takes you and an elephant the same amount of time to defecate. Now, defecate's one of those funny words. You don't ever hear anyone say, hey, I got to go take a defecate, or I got to go defecate. It's always, I got to go take a shit. And I think it's weird that people say I have to take a shit, because I personally don't take the shit. I leave it in the toilet bowl. But that's a conversation for a different day. The article goes on to say the ancient Chinese practiced copromacy, the diagnosis of health based on the shape, size, and texture of feces. So did the Egyptians, the Greeks, and nearly every ancient culture. So get off my back for being obsessed with shit. It's science, and it started with ancient cultures. And even today, your doctor may ask you when the last time you had a bowel movement, and to describe it in exquisite detail. So these fecal doctors are way more shit obsessed than I'll ever be. Sure, it's uncomfortable to talk about. For most people it is. For me it's not, but for most people this is uncomfortable. But that's where science comes in, because what we don't like to discuss can still cause harm. Absolutely, that is 100% true. Irritable bowel syndrome, inflammatory bowel disease, gastrointestinal infections, and other poop-related ailments cost Americans billions of dollars annually. But trying to stem these problems was not our main motivation for trying to figure out some of the physics of defecation. It was something much more sinister. It's fucking weird that physics of defecation is even a thing. I'm sorry. The article continues, from personal observation into the lab. When parenthood hits, it hits hard. One of us is a working dad who survived by learning a new set of skills, one of which was fecal analysis. Boy, if I could only use Dr. Emmett Brown's time machine to go back in time and tell my younger self to get into fecal analysis, things might have been different. Years of diaper changes and then potty training turned me from a poo analysis novice to a wizened connoisseur. My life passes by in a series of images. Hard feces pellets like peas, to long feces like a smooth snake, to a puddle of brown water, and that was a mouthful. The article continues, unlike the ancients, we didn't believe that we could predict the future from children's stool, but we did think it was worth trying to understand where all these shapes come from. Having a laboratory to answer questions about the everyday world is one of the distinct pleasures of being a scientist. As fluid dynamicists, we joined forces with colorectal surgeon Daniel Chu and two stalwart undergraduates, Candice Kaminsky and Morgan Lamarca, who filmed defecation and hand-picked feces from 34 mammalian species at Zoo Atlanta in order to measure their density and viscosity. Boy, I just can't get over the fact that someone has a job where they can hand-pick feces and study the texture. I mean, people think I'm weird. We learned that most elephants and other herbivores create floaters, while most tigers and other carnivores create sinkers. And I like to think I create cloggers. But anyway, the article continues. Inadvertently, we also ranked feces from most to least smelly, starting with tiger and rhino and going all the way to panda. The zoo's variety of animals provided us with a range of fecal sizes and shapes that served as independent pieces of evidence to validate our mathematical model of the duration of defecation. We also placed the feces in a device called a rheometer. I don't know if I'm saying that right, but we're just going to say rheometer for the rest of this video. A device called a rheometer, which is a precision blender that can measure the properties of liquid-like and solid-like materials, such as chocolate and shampoo, and also feces. Our lab shares two rheometers with Georgia Tech physicist Alberto Fernandez Nieves. Once again, I apologize if I'm saying that wrong. We have since categorized the rheometers as the clean rheometer and the David Who rheometer, which has seen its fair share of frog saliva, mucus, and feces. Wow, frog saliva just came right out of the blue. He's mixing frog saliva with feces. I don't know what's going on here. But anyway, the secret to the speed. What else did we learn? Bigger animals have longer feces. So that makes sense. Bigger animals have bigger turds, bigger piles of shit. Smaller animals, smaller turds. And bigger animals also defecate at a higher speed. That doesn't make sense. At the beginning of the article, it says, I shit just as fast as an elephant. That just says an elephant should shit faster than me. Just doesn't make sense, but we'll continue on here. The article continues. For instance, an elephant defecates at a speed of 6 centimeters per second, which is nearly 6 times as fast as a dog. The speed of defecation for humans is in between the elephant and the dog. The speed of defecation for humans is 2 centimeters per second. Together, this meant that defecation duration is constant across many animal species, around 12 seconds, plus or minus 7 seconds, even though the volume varies greatly. Assuming a bell curve distribution, 66% of animals take between 5 and 19 seconds to defecate. It's a surprisingly small range, given that elephant feces have a volume of 20 liters, nearly 1,000 times more than a dog's, at 10 milliliters. How can big animals defecate at such a high speed? The answer, we found, was in the properties of an ultra-thin layer of mucus lining the walls of the large intestine. The mucus layer is as thin as human hair, so thin that we could measure it only by weighing feces as the mucus evaporated. Despite being thin, the mucus is very slippery, more than 100 times less viscous than feces. During defecation, feces moves like a solid plug. Therefore, in ideal conditions, the combined length and diameter of feces is simply determined by the shape of one's rectum and large intestine. Makes sense. One of the big findings of our study was that feces extend halfway up the length of the colon from the rectum. And the article continues, a unified theory of pooping. Putting the length of feces together with the properties of mucus, we now have a cohesive physics story for how defecation happens. Bigger animals have longer feces, but also thicker mucus, enabling them to achieve high speeds with the same pressure. Without this mucus layer, defecation might not be possible. Alterations in mucus can contribute to several ailments, including chronic constipation and even infections by bacteria, such as C. difficile in the gastrointestinal tract. Beyond simply following our scientific curiosity, our measurements of feces have also had some practical applications. Our defecation data helped us design an adult diaper for astronauts. Astronauts want to stay in spacesuits for 7 days, but are limited by their diapers. Taking advantage of the viscosity of feces, we designed a diaper that segregates the feces away from direct contact with skin. It was a semi-finalist in the NASA Space Poop Challenge earlier this year. It just shows that physics and mathematics can be used everywhere, even in your toilet bowl. This article was originally published on The Conversation. So that's the article. I just think it's very interesting that there's people that actually study our fecal matter, animals' fecal matter, why it takes us so long to shit. And I can't believe that mucus is such a vital part of the defecation process. So thank you for tuning in. If you enjoyed this video, smash that like button. Even if you didn't enjoy this video, do me a favor and smash that like button and subscribe to the shittiest channel on YouTube.